Hello everybody. Today in this session 10 we will be reviewing immediate effects of nuclear weapons. People are probably sick of seeing these sorts of things, but the immediate effects are pretty straightforward. Blast is the first one. Everybody's familiar with that. And there are different types of bursts. There's a subsurface burst, a surface burst, an air burst, and a high altitude burst, and there's actually a ground burst. I got this from from FEMA, and they actually missed the land burst where it's exploded on the ground, but there's 5. The flash lasts for less than a second, and this is if you happen to be focused on the flash, which is pretty darn hard to do. You'd have to be focused on that flash at the exact time to be able to damage and get core retinal burns. There's only one instance in Hiroshima of that happening. The fireball lasts less than 90 seconds. And yes, it gets up to hundreds of thousands of degrees, but it's very small radius. You can look that up in the weapon effects tables. It's in the Appendix A of POP. It's very small, quarter mile, even for a large weapon. But it affects thermal radiation. The heat travels at the speed of light. So it's not. I see some of the movies on TV, and they see they have people running away to get away from the thermal radiation. That boy, you'd have to. The only one who could do that is the flash. So it travels at the speed of light. If you have something dark on, just like solar panels and anything dark, it's going to absorb that radiation, and you can see the burns on some of these people based on the color of what they were wearing. The other issue, which has only come to light in the past since about 2005, 2010, is electromagnetic pulse. That is the most damaging, actually, as a weapon. That's one weapon of electromagnetic pulse at the right altitude and in the right place could knock out all the power in the United States. The first EMP was Starfish Prime, 1962, and we didn't have a lot of electronics then, but we still had electric motors and so on. Some of those were actually damaged, and they were far away. So EMP is a really serious thing. It's hard to get a grasp on because it's invisible, just like radiation, and you don't know, and you can't see it. So, but it is the most damaging over the long run. The blast or shock occurs less than 1 minute also. And you can see, depending on the structures, how they react to the blast. Now, in Hiroshima, most of those structures were really light structures, and they had no fire retardant materials then. People were living in literally shacks, and the only commercial building they had was this one here that you see all the time, and it's still there. And the reason people always ask me this, why there were so many innocent Japanese people at Hiroshima, and yes, that is true. But the problem is, at that time, they did not separate the military industries from the residential sections. So there were houses scattered all among the defense industries. They didn't separate them. But so that's why so many people were injured and killed. At Hiroshima, it was a prime target because it was a major communications center. It had Mitsubishi Steel Arms, Mitsubishi Torpedo Works. They were manufacturing cannons, artillery, combat vehicles, and munitions. And all these people had their houses all around these industries. So that's one of the reasons why the injuries and the deaths were so high. This is an aerial view. This came from the Japanese Bomb Casualty Commission, but this shows exactly where the target was, which they missed, I think, by about 300 yards. But that's pretty close. And here's some of the things at that target. These are some of the industries at that target. Neutron radiation, or initial nuclear radiation, is another incredible tool, and this shouldn't be confused with gamma initial nuclear radiation. This is initial nuclear radiation, which is neutron. And the reason why you'd want to use a neutron bomb, I mean, war is a business, and this is the way it works, is they use a weapon like this, they detonate the weapon over a facility. It kills all the people in the facility within usually an hour, and then the attacking force can take over the facility and use the facility to attack the other people. So you don't hear much about that, but that's what's happening there. We learned earlier that the lethal dose is usually about 200 rems, and these neutron weapons will produce millions of rems that will penetrate anything, and death can be within 2 minutes to an hour. So, but that's how they're used, and that's why there's been a lot of conflict over that. And now they also have ammunition for tanks that can be neutron also. And I get a lot of questions about fallout. People say that there couldn't have been fallout at Hiroshima and Nagasaki because they were airburst weapons, so we can't have fallout. But the reality is that the fallout on both locations was based on the bomb casing. So that bomb casing becomes is radioactive, and it's very, very hot. And the only way you can make something radioactive is when it's exposed to the initial flash, the initial surge energy of that weapon. If something falls on a can of food, the food doesn't become radioactive. This dust, this is fallout. You don't notice it's light gray. When you heard of black rain, it's because when, just like in your fireplace, you've got that gray powder. As soon as you put a drop of water on it, it turns black. So that's what that black rain is about. So that dust, when it gets wet, turns to black water. A lot of the people at Hiroshima experienced that. They had dust all over. They had dust from some of the blasts, as the blast hit the ground and created more dust. But the black rain coming down is that dust mixed with water. And yes, it's very hot radioactively. But keep this in mind. The decay rate is relatively quick. It's 30 days. After 30 days, more than 99% of the radiation has decayed. The overpressure that is damaging. This is part of what the weapon does. You've got overpressures that are hundreds of psi, which goes down to maybe 10 psi a few miles away. But this is the way that it actually damages people. At 8 to 15 psi, you're going to get lung damage. At 15 to 20, you're going to get eardrums rupture, and it affects people as they get older more. There's severe lung damage at 20 to 30 psi. Eardrums rupture on anybody less than 20 years old. So these are the things that happen immediately from pressure. It has nothing to do with radiation. Radiation is also there, but that's not what this is about. And here's Hiroshima then and now. This is now a park. Everybody's no one's suffering from all these long-term effects. The average age for the hibikashi for the people who are exposed to the weapons is 77 years old. I have another section for long-term effects, and we'll be talking a lot more about that. But as bad as it was, people have still recovered.